This video is for Arithmetic Series. So if you recall, a series is a sequence where all of the terms are being added together. So we have two types of series that we're going to look at. First, we're going to look at finite series. So a finite series has a specific number of terms. And an infinite series has infinitely many terms. I was actually thinking back to English in high school, like you can't use the definition or the word in the definition. The ... is what tells you that you're dealing with a series. So series are just like sequences, they just have plus signs in between instead of commas. And then if there's no ... at the end, it means we're talking about a finite series. If there is a ... we're talking about an infinite series. To find the sum for an arithmetic series, we're going to use the formula S sub n equals n divided by 2 times a sub 1 plus a sub n. And the 2, it could be n divided by 2 in the very front, or you might have seen this entire thing divided by 2, and both of those are exactly the same. I can't remember which one the state uses, but mathematically speaking, they're exactly the same. We also have a special notation for writing sums, and this works for arithmetic and geometric, but it also works for just any type of series ever, really. So sigma notation uses the Greek letter sigma. Ooh, tricky. That looks great. And they'll always tell you to start on a certain term and end on a certain term. So an a sub n would be like the formula that you're using. So, and it could be the first term, but it could be like the 0 term. Sometimes they have you plug in 0, which is silly. Or the 5th term or something. So I to j, because it could be any random number of things there. So I is the first term that you're finding, not necessarily the first term. And when you find it, it would be a sub I, because you would have plugged in the I. And then j is the last term that you're finding. And the term itself would be a sub j, whatever you got when you plugged in j. Now, this is the part that is going to mess with your brain a little bit. If you want to know the total number of terms between I and j, then what you do is you do j take away I plus 1. This is the part that messes with people's brains. So let's think this through. If you had the first term down here and the 5th term up here, and I said, how many terms are there? You'd be like, duh, there's 5, because I can count, right? But if I said, hey, find the 4th term all the way up to the 8th term, how many terms are in between? And most people would say 8 take away 4. That's what most of you would say. So let's do the math here. If we're doing the first term to the 5th term, that's obviously 5. But if we did the j take away I idea, we would have 5 minus 1 is 4 terms. But really, you know it's 5, so we should add 1 to that. So if we're doing the 4th term to the 8th term, 8 take away 4 is 4, but we should really add 1. And that's because we're counting the 4th term, then the 5th term, then the 6th term, then the 7th term, then the 8th term. So that's actually 5 terms. All right, and that's because you're counting both sides of the end, if that makes sense. So this is a good trick to remember, because I believe in Math 3 you probably usually started on the first term when you did this, and we will often not start there. So that's a good trick to have. Okay, so for the examples, we're going to find the sum. So first, they might say to find the sum of the first 85 terms. Of a sub n equals negative 7 plus 3 times n minus 1. So if I want the first 85 terms, I know my n value is going to be 85. I know my first term is going to be negative 7. And then in the formula, the a sub n is just, if I'm looking for the first 85 terms, then a sub n would be the 85th term. So then I'm going to look for the 85th term. And I'll get that by plugging in 85 right here. And if you plug in 85 right there, you should get 245. So now I'm ready to find the sum. So the sum of the first 85 terms is 85 over 2 times negative 7 plus 245. And so the sum of the 85 terms is 10,115. And you should be like, that's simple, I've done that before. That is true. Alright, number 2. Let's say we gave you sigma notation, or summation notation. I like that because it feels like it rhymes. And let's say we said negative 3k plus 7. So this is the same as this formula. It's just like they multiplied it out, basically, and then combined like terms. Typically in sigma notation, you'll see parentheses around the formula so that you know to plug it all in right there. So for this one, we're looking for the first 76 terms, as I can see, based off the numbers that I'm plugging in. And so first I'll plug in 1 for the first term, and then I'll plug in 76 for that term. So the first term here ends up being 4. The 76th term ends up being negative 221. So I would have 76 divided by 2, and then 4 plus negative 221. Or you could just write 4 minus 221. That would be fine as well. So the 76 terms added together is negative 8,246. Okay, so now I'd like to do one where they don't start on the first term. So for this example, that's kind of similar to what you guys learned last year. We'll do the sigma notation. We're going to start with the 15th term, and we're going to go to the 43rd term. And the formula we're going to use here is 6k minus 13.2. So on this one, the number of terms that I'm going to find is 43 minus 15 plus 1. And so that would mean we're going to find 29 terms. And then we need to know what the first term that we are looking for is, and that's the 15th term actually. And I get that by plugging in 15, so that's 76.8. And then the last term that we are looking for is the 43rd term. And so when I plug that in, 43 would give me 244.8. Right? I don't know for the S sub, the number of terms you're finding. I don't necessarily want to write S sub 29 because I'm not looking for the first 29 terms. So I'm not really sure how to write this, so I'm just going to maybe not do that part this time. So the number of terms we have is 29. 29 divided by 2, and then the first term that we looked for, and then the last term that we looked for, and then I can just plug it in. So 4,663.2. So we would say terms 15 through 43 added together gives you this. Okay. So for the fourth example, we're going to look at a different way that the instructions could be written. They might say something like, find the sum of the series. And then they'll give you a series, so like negative 5 plus negative 1.8 plus 1.4 plus 4.6 plus ... 174.2. So the interesting part about this problem is they gave us the first term, they gave us the last term. I don't know which term this is, and I don't know how many terms I have. So that's the part that's kind of weird on this one. So A sub question mark, because I don't know. 174.2, I have no idea how many terms I have. So for us to figure this out, we should write an explicit form for the sequence. So I can see that A sub n equals -5 plus, if we look at what's happening, these numbers are going up, so I know my d value is positive. And when I find it, I usually like to ignore the first ones that feel weird. 4.6 minus 1.4 is 3.2. So that must be my pattern, times n minus 1. So I don't know what n is, but I do know that the last term is 174.2. And so that means we now have enough information for us to solve for n. So we've got -5 plus 3.2n minus 3.2. So we have 3.2n minus 8.2. And I'll go ahead and add that to the other side, and that gives me 182.4 equals 3.2n. And then when I divide by 3.2, I get 57 equals n. Whenever you do this, I guess I shouldn't have boxed that, it's not my final answer. But whenever you do this, your n can only ever be a positive whole number. So if you did not get a positive whole number, you did something wrong. There's no such thing as the 2.5th term. There's just the second term and the third term. There's nothing in between. So when you find n, it has to be a positive whole number. So now I know that I'm finding the sum of the first 57 terms. I know that I'm going to do 57 over 2, that my first term is -5, my 57th term is 174.2. And then if I plug that in, that means I get 4,822.2 as my sum. Okay. And then probably this is the one that is new, so maybe write that in your notes, new. So this one, they're going to say determine the number of terms in the series. And then they're going to give you a series. So I'm going to keep the same one from last time because we already did some work with it. And then here they're going to say S sub n, and they're actually going to give you the sum. So we know what the sum is, we just don't know how many terms we added up to get there. So if I'm thinking of the formula, on these it kind of helps me out to write down the formula. S sub n equals n divided by 2. First term plus the last term. So, S sub n, I know what that equals. That's 13,224.6. N divided by 2, I have no idea what that n is. I know that the first term is -5. And here's the other weird part. I know that the last term is going to be found if I plug n into this formula right here. Now, I don't know what the n is, but I know that I could find the last term if I plugged it in right there. So I'm going to say plus, and instead of writing my last term, I'm going to say -5 plus 3.2 times n minus 1. So this is going to stand for my last term. Do you like all those parentheses? So at this point, I know this problem looks complicated, but for you guys, this is just going to be kind of a nasty simplifying problem that is honestly like math 2 level math. It just looks crazy, but it's actually totally within your ability to do. So we're just going to start to simplify this right side because there's a whole mess happening here. So I'll distribute that. So I've got -5 plus 3.2n minus 3.2, and I still have the -5 in the front. oh, and the n over 2. And then if I guess I don't need these inside parentheses anymore. There we go. So now I can combine all of those like terms. So I have 3.2n inside, and then that makes negative 13.2. And I still have the n over 2 in the front. And they always work out like this, so once we do it once, we'll kind of have an idea. What I usually like to do next is get rid of the divide by 2 part, just because I don't like to deal with it. So I'm going to multiply by 2 on each side, so that's going to mean I don't have a fraction anymore. So now I've got 2644.9.2. And then if you guys are okay with it, I'm going to go ahead and distribute this n now so that I can completely get rid of my parentheses. So 3.2n squared minus 13.2n. And what you see right here is we have a quadratic. So that's good times. So I'm going to minus this number over. I've got 3.2n squared minus 13.2n minus 26449.2. And that means that for me to solve this, I have to do the quadratic formula. So I'm going to plug in a fraction for the quadratic formula because that's easier. I have negative b plus the square root of b squared minus 4 times a times c all divided by 2 times a. Now that equals positive 93. That looks like that's probably the answer. But since the quadratic formula has a plus minus, I should try the minus version just to see if maybe we have 2 possible answers. I hit second enter for those of you who are like, what magic just happened? Second enter will put it back on the screen for you. Put a minus in. Negative decimal definitely can't be the term number. So that means that what we just did, this number right here must have been the sum of the first 93 terms.